Good evening, everybody. My name is John. I'm a Romanian auto electrician working here in England. Most of my work is diagnostic, wiring, ECU modules, and repair that other people often replace instead of fixing. So today I'm doing this live from the bench, so you'll see the real process, test, mistakes, because mistakes can happen too. Thinking and repair work as it happens. So I also have my companion over there. That's Dexter, my AI bench partner. He helps me organize the diagnostic steps, explains what we're testing, and keep an eye on safety and privacy while I do the hands-on work. And this is not a polished TV, a polished TV, more polished bench repair video, so it's raw. Yeah, like real workshop repair. So let's get going. So we have the bench here. We have an ignition switch for Mercedes Sprinter. I think it's about 2010, 2011. The key is not being recognized, so we don't know exactly if the problem is with the ignition switch or the problem is with the key itself. Meanwhile, what we're gonna do, we're gonna test the key, but let's get Dexter to introduce himself. Next. Good. So now, meanwhile, what we're gonna do, we're gonna take the key out. We're gonna inspect to see if it looks okay. It's a bit dirty, but it's normal.
Hello everyone,
So
I am
let's see
Dexter,
what's happening
John's AI bench
here. Let's open
partner.
it up.
I help keep the diagnostic steps organized, explain what is happening in plain English, and watch for safety or privacy issues, while John does the real hands-on repair work.
Good. So Dex introduce himself. Nope, that's good. So let's see what else we have here. Let's put this aside. So this is how it looks. It's basically a normal ignition switch, pretty much the same principle like all other ignition switches that Mercedes built. We have like a key in, this is the switch that recognizes the key it's in. As you can see, when I push it in, it slightly moves and it's recognizing the key. It has a switch right here. So let's look at the lens first, because this one it's sometimes getting dirty. The lens looks okay to me. Let's clean it anyway. Don't see not too much dust on it. Let's get it out. Let's clean it a bit. Meanwhile, let's test the key as well. Okay, so where we are, let's move this. Good. So let's see what else we have here. Good. Let's put the key in the key reader. Over here, I'm gonna put the key here, and then let's go on this program and let's press identification. Oh. So it looks like the key is not programmed, or it's faulty, as it says unused. So most likely that is the problem. So what we're gonna do now, we're gonna start multi-prong. Let's bring it up. Good. So we're gonna start the device. We're gonna look W906 and we have it here. I think that's the one. We're gonna have details, connection diagram. Let's see. Yeah, that's the one. I'm gonna use those ones. So we're gonna connect and read the ignition switch to extract the data, because I think the problem is with the key itself. Okay, so let's go and do it. So let's go back to the main scene. Good, perfect. Get a little bit down this one. Good. Let's put some flux on here. And this and this. And problem is, one of the pins has been ripped off. Exactly one of the pins that we need, I think, is one of this. Let's have a look. Yeah, BKGD. So BKGD, as you can see, is being ripped off. Exactly there. But lucky for us, we still have like a contact, I think, somewhere here. Yeah, that's the contact. Perfect. Yeah, so that's not a problem at all. Okay, let's solder it over there. Get the multi-prong. Let's find VDD, VCC, VDD. And let's find ground, VCC. We find ground, VCC. Perfect. So let's see where it goes. So ground will go here. That's ground. Connect the VCC. Perfect. Then we're gonna go for the crystal. Let's see, where's the crystal? Crystal is over there. I've done this multiple times, but I never did it live. But it's a first time for it. Everything, I think. So let's put the ground here. Perfect. And the signal there. And now we have to put the purple and the yellow, which is reset. Okay, so let's see which one is first. Purple is the first one. And we'll go here. Purple. And then we will go here. Perfect. Now let's give Dex the analyzers with the key and see what Dex has to say. And send it to Dex. So let's see what Dex says about the key data. Meanwhile, we are okay. We solder them good. All the soldering, it's okay. Nothing gets touched. As you can see, ground signal over there. And we have here positive 5 volts in the ground. So now we will connect on the
What we are seeing here
On the
is a Mercedes
multi-prod.
BE key that reads almost completely empty. The EEPROM area is
Connect on
all
the
zeros.
multi-prod.
The status is unused,
And
and there is no valid
should be
key
able to read
password
it.
or rolling data. That means the
Let's have a
EZS
look.
has nothing trust.
Let's press OK. Let's press read. Okay, not connected, of course, because I got the other one. Let's unplug this one. Let's connect it here. Perfect. And now let's press read. Okay, so the chip has been recognized properly. Now it's trying to unlock it. Yeah, perfect. So we got the chip read. That's perfect. Let's scroll down. We should see some pieces here. Yep. That's good. That's good. So this is the data inside of the ignition switch. We're gonna save this one. Go press save. I'm gonna make another folder. Press OK. So now we have the EEPROM where all the keys are stored there, and the VIN number and everything. Now we get the flash. The flash data has a lot of other things like car configurations, like coding, like a lot of communication protocol between the ignition switch and the rest of the car. Because on Mercedes, the ignition switch, it's basically like the main getaway. So as you can see, it's reading. So like I said, the ignition switch is the getaway for this car model, and in general for Mercedes. Some of them have a dedicated getaway control module, like an S-Class or some E-classes as well. But on this one there is no getaway control module, and the ignition switch does all the CAN multiplexing and things like that. So let's see. Let's see what Dex has to say. I think we already done. I think we should be good. We will inspect the data in a minute.
Now John is reading the EZS, which is the Mercedes Ignition Control Unit. The aim is to recover the authorized key data from the vehicle's own module, then use that data to prepare a correctly matched replacement key. This is not guessing or bypassing the car. The new key has to match the security data already stored inside the EZS.
Yeah, that was quite an explanation from Dex. Yeah, Dexter, it's my AI assistant. He runs locally. He knows pretty much everything about the business we're doing, and he knows where we are live, so he helps me to structurate the videos, because it's the first time I'm doing this, so I hope I'm not gonna be judged too thoughtful, too bad. But with time, most likely I will become better. Good, so now we did all this. Let's see if there is any short circuit under the microscope. It looks okay here. Don't really like bad soldering. And that's okay. That's okay too. Perfect. So we know that the key is no good. We can try to program it, but it's not doing. Look, when you press it, look what it happens. The button's supposed to light, the LED in the key is supposed to light up once and turn off, but when I press it and keep pressed, it stays on. And now look at the other one. Look, a new one. I have a new one. Does once and switched off. And we can test it now as well. Let's see the key. So we have the flash. Good. Now let's save the flash as well for a full backup. Let's save. And now we're gonna go for this identification. So this is how, not 00, this is how it should look. So now what we can do, now we're gonna prepare key file. So we're gonna find where we save it, desktop, load, and we're gonna load the EEPROM, and we're gonna generate, select all keys. Looks like only key 7 was enabled. Prepare key data. And now we will wait. See what's happening. We should have keys and we should be able to test it in a couple of minutes. Good. So I think we should go for key number 1. Let's see if, okay, we got the new key here, and we're gonna load one of the keys that has been generated. All files. Why we get only key 7? That's a bit weird. Let's go back, prepare key file. We need to generate all. That was only, no, load key file. EEPROM. We need to tick manually all the keys. We're gonna load, prepare key file again. And I think we will use key number 1. Let's see if it works. Let's see what's happening. It should generate all of them shortly. And after that, we're gonna use our main emulator, because this ignition switch we will not be able to test it if we don't have like a steering lock emulator, and this emulator will work with any ignition switch, and it will allow us to lock it and unlock it. So we keep the old one here, and now I think my suggestion will be to put this one together. That's it. That's it. And then let's find the 2 screws that came with it. Good. That's 1 screw. the second screw. That's perfect. And now the keys are generated. And we go back up, identification, we have the new key in. We're gonna load key, we're gonna do, oh, it's disabled. Okay, that's why it was not. Okay, so we got 8 keys, but a few of them are disabled. Okay, let's see if it's working with key 7. Otherwise we need to make this ignition switch virgin and then re-enable all the keys. So let's see, key 7. Right. So it's writing now. Good. Right, that and now it should be key 7. Good. Now let's do, where is it? Oh, here. Let's find the ignition switch. Pinouts. Good. Okay, so this is the ignition switch. This is the communication wire that goes from the ignition switch to the steering lock. This is positive and this is ground. So let's connect them on the bench and see what's happening. So we have the emulator here. We have positive and negative, brown and red, and green it's the signal. So let's connect brown and red. So red left top, brown, okay. It's pretty much everything. And next one we should connect with the crocodile clip. We'll connect to the first one from here. There's the signal. There's the signal for steering lock. Good. And now let's put some power supply to it. Let's see what's happening. I'm just gonna put the key in. Ah, so we are allowed. Perfect. Take it out. Good. In. Not working. It only worked once. Yeah, that's it. Only worked once. You see, it's not unlocking anymore. So we need to go and make this ignition switch virgin and then use it again, and then it's a bit more complicated, but it's doable. I think I'll need to get some cables. Bear with me. Some cables here. Don't have an adapter for this ignition switch, so we're gonna improvise one of the VVDI. I think it's from a C-Class 204. So let's improvise it, so we will be able to read it on the bench, because we need CAN lines. As you can see in this picture, we need on this CAN high, CAN low, and power, so we'll be able to read it. Good. Now let's solder some wires from here. Yeah, this is happening after a lot of keys are written into the ignition switch, or depends. Sometimes it's happening when people are using different kind of tools to write the key, and they don't read the data the way I read it now. Let's find some other some DuPont cables. Yeah, found them. Not the right ones. More. Okay, so I have some cables. I have one, but we're gonna cut it and we're gonna make two. So I have those connectors that will go in the ignition switch for the CAN wires. So like I said, this is not staged, this is live repair, this is how I will do it in a day in the workshop, and I wanted to share with you. Let's see what's happening. So we got the two lines here. Good. Let's see. I'm gonna go for this one and this one. So top one is CAN low, bottom one is CAN high. Good. Now we will connect the VVDI connector to this cable. We already have power, but I think we should get the power to the OBD connector as well. Oh, alright, black and red, perfect. This is a bit of an improvising, but sometimes you have to do it. I have plenty of connectors like this, but I was not prepared for this. I was prepared for a usual normal ignition switch problem, not this kind of ignition switch problem. Usually the video will be end by now. Okay, so we connected this, and now we need to connect the ground. And okay, can go out of here. This one more. So I have the CAN bus connected here in these two. Now we'll need to connect positive. Just gonna make a bridge. That's one. That's two. That's one. That's two. So we'll connect the red with red. I don't want to cut the wires, that's why I'm doing it like this. Red with red and brown with brown. So now the magic should happen. I think it will work. It looks a bit messy, but it will work. I've done it plenty of times. So let's go on desktop first. And let's go on VVDI. Okay. And let's go ignition switch. And now we will select 906. Read that up. My OBD. Let's see if it's connecting. No, let's swap the CAN bus. CAN bus is no problem if you put them the other way around, CAN low with CAN high, it will not communicate. But if you put the negative with the positive, then it will be in trouble. Okay, read it. There you go. So as you can see, it's only used number 7, but they only used once. So I'm not happy with this. Okay, let's load key file again. So we need the key password. We're gonna copy this. Go in ignition switch. Go 906. Read. We're gonna paste the key pass. We're gonna get the erase password from the server. Good. Then we'll need to save it in OBD format, because at the moment we only have the backup that we read with the multiprog. That's the raw backup, so anything can happen. If anything happens and we mess it up, we can always go back to that original state, and we can always take it from there again and again. So this is the best way to work, is just to make sure you have the backup first, and then you don't need to worry about anything. Even if the ignition switch fails completely, you still have the data. That's the most important thing. Good. So we have, it's still calculating the erase password, because we will need the erase password. And good. Okay, so we're gonna save data. Perfect. Save. Perfect. And now we're gonna go to renew it. Renew EZS. Now what I'm gonna do, I'm just gonna insert the VVDI adapter into ignition switch, because we need to have it. Okay, as you can see, erasing success. Good. Now we're gonna go on the OBD. We're gonna have load the ignition switch data. Okay, not depot. Should be like a 4 kilobit file. 1 second. Let's try this one here. So we're gonna go by ear, infrared, and we're gonna go write ignition switch data. Better write the VIN. Let's see the VIN number. Why the VIN number is not showing? Let's open this. Let's open this. Okay, where are we gonna go? Desktop. Sprinter. What we are trying to check, we're trying to see where is the VIN number and why is it not showing. Okay. Actually, I'm able to see the VIN number. Nothing on this. It should be somewhere. Yeah. 906. What? No. Cancel. What will be it? We're gonna do it without the VIN number. We can always add it manually. Yeah, right, EZS data, yes. It's writing data via the infrared adapter. We will see all the keys. They are not disabled anymore. They should be available. But let's go on OBD. Read ignition switch data. You see, they are not disabled anymore. Perfect. And now if we're gonna use our key, number 7 key. Oh, that's good. Read again. You can see that number 7 key should be activated. Let's try one more time. No, still not working. That's weird. Ah, there you go, number 7 key is activated. So now if we're gonna write it, let's write this key, let's put it on position number 1, for example. Read write key is number 7. I don't like this, the use time is 6677. So let's write one number 1 key, for example. Right. Let's go identification 28,000. Load key file. Let's write number 4. I'm trying to find one with less and less usage. So let's look now. Oh, use time 3 times. Remaining times. They have a counter, so just so you know, sometimes, especially the FBS 3 generation, all of them have a counter. So in out is registering every time you put the key in, you take the key out. So after one point, they will stop working. So, but this one is. Sorry, you didn't see it. This one key number 4, it's used 3 times. So now we're gonna insert it. Okay, hear the sound. We're gonna go on the ignition switch. We're gonna go 906. Read ignition switch. Good. And now we should see number. This off. Now we should see. No, number 4. No. Should come in. That's weird. So it's unlocking, but it's not. Just to reset, remove the battery, the power supply, connect it back. Still does not allow me to unlock the ignition switch. Good. So we have all keys used now. Now what I will do, I will load the ignition switch. Let's load the password. The EEPROM. Load. That's because it's opened by this. 1 second, let me close it. Good. So let's get the password. Copy. Let's go to ignition switch and let's regenerate the keys after we enable all of them. With the ignition switch, let's press paste. Let's get this one. Good. Now save. I'm gonna save it. Good. I'm gonna save it there. Yes, and now we're gonna generate other keys based on the new dump. Ah, there you go. Look, all keys are enabled now. So most likely the keys will be different. They will have different key hashes, and now they will be accepted. Because originally, as you can see in the video, originally they were like not accepted. Okay, so they generate. It's generating new keys now. I'm gonna put the key back in, and we're gonna regenerate a different key. We're gonna write the key file after we enable all the keys. because I believe that's why we're unable to turn the ignition switch on. Okay, meanwhile I'll give the file, the bin file, to Dexter. What is it? One second. And ask him to extract the VIN number. Okay, extract. Good. So let's see if we have. We should have it here. On desktop. Where is it? That's it. Let's make a new folder. Let's save all of them directly. Perfect.
That warning only means the chat system cannot preview a .bin file as a document. For this job, a binary dump is completely normal. It is a raw snapshot of the EZS memory, not something meant to be read, like text. The key software reads the structure inside that memory and extracts the authorized key data from there.
Now let's see. I think Dex explained to you guys what a binary is. So let's go here. Identification, key number 4. Let's go back. Key number 4. We're gonna go and write a key file after we enable all the keys. Key number 4. It should have different bin number. You see, the binary changed. We're gonna go right. Okay, identification, good. So now we take the key out of the PVDI, put the key in. Oh, there we go. Yeah, so let's see. Let me show you as well. So now take the key out. We put the key in. You hear the click, and now we're able to move it. Take it out. In. Perfect. This is the way it should be. And if we look at the original key, the one that basically when you press it, look how it should work. It should work like this. You press it once, even if you keep the button pressed, look, it's still on and off. And this one is on all the time. So it's definitely wrong. I don't trust this key at all. So let's try it anyway. Nothing happens. Nothing. So I think we're gonna make 2 keys for this customer. So let's keep this one there. Now let me unpack another one. Perfect. This one is not moving at all. So let's write it down. Let's see what position should we do. I think all of them should be reset to 0 now, because number 1 had 22,000, I think. Let's see, load kit file number 1 and write, and we'll see how many use times they have. Usually after you do the virgin, after you make the ignition switch virgin, the usage reset as well. Yeah, so usage reset on number 1 as well. So now is number 1. Now we're gonna take it out from VVDI. Got the old one there, and now we make another one. There you go. This one works too. Yeah, so yeah, this is this was a complicated repair, but because I did it before, it become like, I don't know how. I just managed to know. I memorized. I stored the procedure properly, and I know exactly what to do. Because I had it two or three times. I had it before, and I found that this is the easiest way to get it done, instead of replacing the whole ignition switch, the whole ECU, the whole lot. Because we still have access to the core data, where the keys are stored, and the personalization between the ignition switch and the ECUs are stored. So we don't need to replace the ignition switch at the moment. This will work for a very, very long time. Sorry about the cables. It's just the way sometimes you need to improvise, because if you don't improvise, you need to keep buying cables, and you don't find to buy the cables that you need. And the next one, I think we should have, I think for the next video we will have the new generation Sprinter, like 20, I think it's 20, what year is it? It's 2020 onwards. This has a big problem with water going into them. We have one module on the table. Let me look on the microscope, you'll see it in a minute. Yeah, somebody was trying to... second. Yeah, that's perfect. We have a bit of work here done by somebody else. Here, here, here. Yeah, and the one that I'm speaking about is the Sprinter that has a second, this type of key. Yeah, the new key. This is 2019, 2020 onwards. And usually what happens, because it's fitted on the passenger side, it's water coming in, and like you saw, it's basically frying the model. I mean, literally, I will say it's a lot of damage caused on the model. Yeah, once again, thank you for watching, and I'll see you in the next video. Thank you.